Good Tuesday to you, everybody in Gov 603. Welcome to week 4 again, and the review of the discussion, the readings, and your answers to the questions for week 3. How you doing? All right. I'm back. I changed my shirt. Just nothing on this one except for some lint. Shall we get rid of that? Okay. So, as I noted in the first video, this week we're going to be distinguishing between correlation and causation. And by the way, when I told you to remember the adage that correlation is not causation, I'm not implying that it's never the case that correlation is causation. In fact, when you look at a phenomenon and the two things are happening at once, it's a good point to start from to say, I wonder if this thing, which is happening at this time, is causing this thing, which is happening at that time. But here's the important part. Don't assume because this thing is happening when this thing is happening that the one is causing the other. All right. So the example that I gave was of eating ice cream and incidents of drowning. It could be that eating ice cream raises your chance of drowning. I don't know, but you'd have to set up an experiment. You'd have to set up a study. You'd have to set up an empirical process to investigate if there's any causation. Okay. So just because something happens at the same time doesn't mean it caused it, but it doesn't mean that it doesn't. Right? You have to investigate. Okay, let's take a look at what you read last week and what you said. Okay. Last week was in part about defining terms, and then I put some stuff in there to sort of get your brain turning and thinking about what we're doing this week, and that is looking at causation. Okay, so let's take a look. Question number 1, describe and define the following terms: mean, median, mode, standard error, variance, and standard deviation. Right? These you got to get these terms down and just get them down cold. All right. Not only to be able to read and understand the statistical side of empirical research, but you're going to be tested on them. So there's that. Sad scene. Last of the coffee. All right. Okay. So let's take a look. Nicole, I think you hit this one pretty well. Mean defines what if you add up all the observations you have and then divide by the number of observations. So for example, the mean, here's your observations: 7, 26, 26, 56, 15, 7, 26, etc., etc. Let's say how many times a first grader can jump up and down in 1 minute. And then the mean would be the average time that a first grader can jump up and down in 1 minute. You find that by adding all the times together and then dividing by the number of times that you've recorded. Okay, so 7, 26, 26, 56, 15. That's 5 numbers. Total there is 130 divided by 5. The mean is 26. Not to be confused with the median, which some people do, but you won't because very smart. Back to you, Nicole. The median is the 50 percentile or the middle of the data. The median gives the represented observation and describes when variable is highly skewed. For example, we're back to the 7, 26, 26, 56, 5. 26 is the median since that's the middle of the observation. So you had first graders jump up and down in 1 minute. The first one jumped up and down 7 times. A little lazy cuss. The second one, 26. The third, 26. The fourth, 56. Go, man, go. And the fifth, 15, right smack in the middle would be number 3 at 26. That is the median. Okay? Don't confuse those two. All right? Mohammed, let's see what you were doing for this. Mode. The mode is the value that appears most frequently in a data set. It is a measure of frequency and indicated the most common value. A data set can have one mode, unimode or multi-modes, or no mode at all. Okay, so for example, you get in the data set score of, and this is exam scores, 85, 90, 78, 92, 88. There's no mode because there's no repetition. but in the age of kindergartners in class, 4 years old, 4 years old, 5, 5, 5, 5, 5, 6, 6, 6 years old. All right, there are two modes, 5 and 6. Now, depending on what you're doing by way of research, you might say that there is one, and that's 5. It's the one, it's the number that appears most frequently. Oh, right? And you go, okay, so why should I care? Well, again, let's say back to kindergartners, the age of kindergartners. Let's say you wanted to find out, there's developmental differences between 4-year-olds and 6-year-olds, and there is, but we'll just assume that there's a whole bunch for this discussion. So you're trying to design a curriculum for the class, and you want to find out, well, how many of these 4-year-olds or 6-year-olds or 5-year-olds are there, and therefore the bulk of the curriculum speaks to 5-year-old development. But you still have to have some for the 4-year-olds and some challenging stuff for the 6-year-olds. That's the mode. Okay. Standard error. The standard error is an estimate of the standard deviation of a data set. Now these last three, standard error, variation, variance of variation, and standard deviation, these can be a little confusing. Okay. So I want you to make sure that you understand these. Looking through some of your answers, I can see some of you did not. Richard, let's take a look at what you did. The standard error indicates how close the sample mean is to the true population mean. All right. So here's something that sometimes unnerves some people about quantitative statistical research. We like to think of ourselves as these, distinct individuals. But by way of behavior, we're really not. Our behavior falls into some predictable categories and ranges. And advertisers certainly know that. Google knows it. Amazon knows it, I guarantee, right? If you spend any time online, you might as well, when you spend time online, bear in mind, anything you're doing online, you might as well be standing out in the middle of your town, naked and doing it. There's a whole population out there that's watching every keystroke. And they take that data and they establish patterns of your behavior. Now, all patterns of behavior can be described in a bell graph or a histogram, with the front end being the lowest frequency of whatever the thing is. And then as it rises towards the top, towards the middle of that bell curve, okay, then that's the most common, and then tapering off out in the extreme. All right. So for the population, there's a lot of behaviors that broadly across thousands of people, we have established bell curves. Standard error tells you, if you're looking at a subgroup of the population, let's say you've got 20,000 people, and you're looking at their voting patterns. What time of day, how far from their house do they go? All right. We have really good, rich data for that gives us a bell curve about the average of what time of day is the average that people like to vote. How far do they like to travel from their house on average? There's going to be some people that are on the front end of that, and some people way out on the other side that, vote at crazy hours and go long, far. Okay. But right smack in the middle. Now, if you do a study on, say, 1,000 people where you live, you can look at standard error to see how far the mean deviates from the population. All right, the standard error is calculated by dividing the standard deviation of the population by the square root of the total number of observations. Okay. Variance. Variance measures the dispersion of data from the mean. So this is really important. Where's my magic book? Here we go. Let me grab it. Excuse me. All right. Variance is important when you're doing statistical research because you always want to make sure that as you enter your data in and as you gather data from a population, you want to make sure that the observation that you're making isn't being pushed one way or another by what are often called outliers. That is, things in the data that really stand out and impact the data. Let me give you an example. back to, let's stay with the first graders. Let's say you wanted to find out what was the average amount of time a first grader could jump up and down in 1 minute. Why do you want to know this? Just because you do. So you talk some teacher into letting you into his first grade class, smooth talker, and you say, okay, explain what you're going to do. And he's like, yeah, all right. So you get up in front of the class and you go, okay, kiddies, I got a great game for you today. It's called the jumping game. And what we're going to do is I'm going to call you up here one by one. And then when I say go, you start jumping up and down. And then when I say stop, you stop. The kids are sort of looking around going, oh, all right, and if you do it, I'll give you a sucker. You're like, whoa, hey, okay, that's great. Says the kid. So first kid comes up and it's a girl. Her name is Janie. And you say, ready, set, go, Janie. And she starts jumping up and down. And let's just say hypothetically in 1 minute, little Janie can jump up and down 50 times. And you're like, great. So you write down 50. And then you do the next child. And that child jumps up and down 45 times. And then you do the next child. And that child jumps up and down 53 times. And then the fourth child up is little Johnny. And he ain't down for this jumping game. In fact, he thinks you're kind of dopey. And this whole thing looks stupid. And he gets up there and you're all right. Okay, Johnny, ready to start the jumping game? Ready, set. You hit your stopwatch. Go. I said, go. Come on, Johnny. Jump up and down. And Johnny's just standing there. He doesn't jump at all. Tick, 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 tick. The time goes by and you're trying really hard. Come on, Johnny. Come on. Johnny doesn't budge. Now, the fourth entry is a 0. Now, after Johnny, it's Michael's turn. And he's got a bromance with Johnny here. He thinks he's pretty cool. And if Johnny isn't jumping up and down, now Michael was enthused, but if Johnny isn't jumping down, Michael's not sure. So you're like, okay, Michael, you ready? It's your time, and said go. And you hit the stopwatch, and Michael's like, yeah, come on, Michael, I know you can do it. And Michael's, yeah, all right. And he jumps up and down, a few times. And you have to coax, and the minute goes by, and it's 15 for Michael. So now you've got a 0 and a 15. So you've got 5 points of data, but 2 of them are extremely low. What do? If you put them all into your calculation, see what you're looking for is a nice bell graph that gives the number of times, hoppity, a first grader would jump up and down over a length of time, like that. But because those 2, number 4 and 5, Jimmy didn't participate. He's like, number 4 didn't participate, and number 5 was influenced by number 4. What you get is a graph that looks like this, that starts out good, that is the number of times, but then towards the time, it like tapers off and it's all bunched up over here. Okay. You want to look for that when you enter data into your data set. And what do if you get a real variance from a normal distribution? You throw those numbers out. Now, some people might say, well, hey, now you're manipulating the data to get the answer that you want. No, you're not. Because remember what you were trying to find out. You were trying to find out how many times, the average number of times a first grader could jump up and down in a minute. You weren't trying to find out how long it took an adult to motivate a first grader to jump up and down. Now, that might be an interesting study. Okay? But that wasn't the study that you were conducting. You were looking for the average number of jumps in 1 minute. So the non-jumper and then the non-jumper devotee, sort of his little acolyte, his follower, messed up your data. You have to throw them out. So when you're doing empirical research, when you're doing quantitative research in an empirical study, and you get a weird variance, you have to go back into your data and look to see what's causing it. That's what the variance is, and that's what it's for. Okay. Question number 2. List and describe the 5 variables in chapter 3. Now, I will tell you that some of these terms are not really used that much, are all uniformly, but there are a couple here that you really have to know. Continuous variable. This is Heron. Let's take you. Continuous variables are variables that could take any value, perhaps with some range. For example, monthly income of South Africa would be a continuous variable. Okay, so that's good. But to put it another way, continuous variables have no defined, and when I say defined, I mean defined by you, the researcher, start and stop point. How much somebody makes, how many times somebody could do something like jumping up and down. Now, here's the thing that you need to keep in mind when you're doing quantitative research, excuse me. You can describe any event as a continuous or a categorical variable. It just depends on how you want to describe it. So continuous is that it's got no set start and stop point, set by you. Let me jump to categorical variable. This does have a set stop and start by you. Okay, so things that fit into categories like gender, that's a categorical variable. All right. Now you could, let's say you wanted to do research to see how, if there was any correlation, why is this coming to my head? I don't know, my twisted brain. Is there any causation between being elected to an office and smoking? Do people who are elected to office tend to smoke? All right. Stress. Okay. There's a lot of social settings. Maybe not. All right. So you could take a bunch of elected officials, and first thing you want, because they're all elected. So first thing you want to do is find out how much they smoke. So you could describe that as either a continuous or a categorical variable. You could just say, tell me how many cigarettes you smoke in a day. That would be a continuous variable. Or you could hand them a questionnaire on which you had spelled out in a category some possible answers. Like say, please mark which of the following most pertain to you. Number 1, I smoke 1 cigarette a day. Number 2, I smoke 2 cigarettes a day. Number 3, I smoke 20 cigarettes a day. Number 4, I smoke 40 cigarettes a day. That's a lot. That's 2 packs. Number 5, I smoke more cigarettes than I can keep track of. So now you've set up categories for what is continuous activity. So how the variable is described is up to you. All right, but let's continue. So continuous variable, count variables are those that count something. And this is a term that's used interchangeably for categorical variables. Perhaps how many times something happened, or how many of something there is. Ordinal variables are variables which have values that are more or less, but there's not necessarily any rule to how much more there is. Ordinal variables, age is often described as an ordinal variable. Categorical variable, we just talked about. Qualitative variable. Qualitative variables are sort of catch-all category for everything else. They aren't numeric in nature, but they're also not categorical. The text of a Washington Post headline is an example of a qualitative variable. So what sort of words were used? Now, again, anything that you study, you can determine how to describe the phenomenon. See, a variable is not a thing. Like say a continuous variable is not a thing like my coffee cup is its own thing. It is an expression of how you're describing an event. All right. Do you understand that? And if you do not, if you're, it's like, I'm confused about these continuous and categorical variables, email me. The 2 most common variables and descriptions of variables that you're going to encounter are continuous and categorical. All right. Okay. Question number 3. Sort of pick your brain here a little bit. I gave you a short video to watch by Dr. Jordan Peterson. I think I mentioned this individual before. And if you're not reading him, you need to be. Let me grab a book here. Excuse me. Da, 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 da. Let me recommend 2 books by the good Dr. Peterson. Okay, his first book called Maps of Meaning. All right. This thing is, I think, this is one in my, and I read a lot. This is one of the defining texts of the 21st century. Okay, it's sort of like Infinite Jest was for the 20th century. This is a very dense book, but it is well worth your time. I have read or listened to it because he reads the book. This book probably, no kidding, 4, maybe 5 times. And each time that I go through it or each time that I listen to it, I still get new nuggets. And you might be saying, wow, that must be some book. What is it about? Well, in this book, Dr. Peterson asks the question, how is it that things mean something to us? That is, how do we assign meaning to things, individuals, action? What is that mental process? If you're in politics, whether you're running or you're supporting someone who runs, or you're working on the back end or a front end of a campaign, or you're in a official's office in some capacity, I highly recommend this book because it'll give you an insight. And he looks at peoples and cultures across the globe. He gives you an insight into how it is that people assign meaning to things. And you might be saying, well, that's awfully vague. What do you mean by meaning? Well, let me give you an example. All right. Let me show you 2 objects: my coffee cup and a ring that I wear on my right hand. You know, my left hand is my wedding ring. All right. I could just as well use this. Let's say the meaning of value. All right. What process would I go through to assign value to this cup? Well, I might remember how much it cost. I might think about, just, and we're not talking about deep thoughts you spend all day like going, in passing, where it came from. Maybe it was just in a set that, my wife bought and it appeared in the cupboard. I'm like, all right, coffee cup. Okay. So the value that I assign, how much is this cup worth to me? So if I dropped it or if I lost it, I go, meh. Okay. Comes from those experiences that aren't necessarily inherent in the thing. Okay, what do I mean by that? In other words, how much this cup cost is not, I don't want to pour coffee on myself. It's not printed on here. I mean, witness when you give someone a gift, you take the price tag off. Because if they see a number, that influences the meaning of value. Now, before I go to my ring, let me use another example. So I do a lot of hiking, so I, use these water bottles. Okay. And I'm in the sticker club. Here, let me pull one from back here too. All right. So I plaster my hiking bottles with stickers. Okay. So this sticker right here. See that Park Cafe Breakfast Club 2004, sort of a pirate theme with a couple of eggs and a couple of pieces of bacon. All right. Now, I absolutely can assure you that by way of expense, this sticker was less than this cup because this sticker was free. It was given to me free. But I got this sticker when I went for a very, very long hike with my son and my nephew, 110 miles. It took us like 11 days. We did a mountain pass every single day. And I got this at a breakfast place that we go to in Salt Lake City, which is my hometown, when we go back west to backpack. All right. So the memory that I've assigned to this, when I see this sticker, when I drink water out of this Nalgene, that's what this thing is called, right? the meaning by way of value is greater than this cup, although the value in terms of monetary amount of the cup is greater than the sticker. This book explores how it is that people assign meaning. And if you want to figure out what's important to people and how to talk to them about that, read this book. Okay? So back to the question. So that's one book. I said there was two. And then, and this is more his more contemporary work, 12 Rules for Life. Read that book too. All right, but back to the question. So I asked you to watch a little video from him in which he goes over the Pareto principle. Okay. Now a lot of you, when I asked you to explain what this is, and I'll ask you again on the test, you didn't quite get it right. So let me tell you what it is. The Pareto principle says that in the exchange of anything, in this case, you could use monopoly money or tokens, or if you gave people, a roll of quarters. I think quarters come in $10. If you just start exchanging, even if you exchange one for one, the randomized, we think of random as like chaotic, and that's not what it is. Random means that as far as we can see, there's no force being exerted on it. So there's no one telling them, well, now this side of the room give their quarter to that side, but that side of the room give 2 quarters, and this side give now 5. Okay, that would not be random. So in a random exchange of, say, monopoly money, back and forth, back and forth, back and forth, the distribution of that money as the exchange goes tends to skew. So somewhere in the order of 15 to 20% of the group gets most of the money, and then there's a very steep drop off for the rest of the 80%. And by the time you get past about 50%, way out towards the end of the tail, there's zero money. And it's a mathematical principle. It happens regardless of the force that you exert. And it seems to happen regardless of the force that you do exert. The Pareto principle governs the distribution of ideas and things. So I asked you, well, what kind of implications would this have for policies, the way we think about solutions for, political, social problems like poverty and economic disadvantage and all that sort of stuff. All right. So Cynthia, let's see what you were doing. According to the Pareto distribution principle, approximately 80% of the outcome results from approximately 20% of the cause. This has been applied to everything from creative output to intellectual capacity to stock trading. Peterson points out what is commonly referred to as the Matthew principle. To those who have everything, more will be given. Those who have nothing, everything will be taken. When applied to poverty and economics, the principle complicates what would seem to be practical solutions if the Pareto principle is accurate. And I mean, to answer that supposition, Cynthia, it is. Mathematically, it just works out this way. Even if the government forced every citizen to begin with the same amount, many people would still end up with zero, which would then be made worse by the fact that having zero removes you from the proverbial game, that is the game of exchange. And what happens is, as the number of people that are removed from the game because they have nothing to exchange, the Pareto principle is constantly running. And so let's say you start with 1,000 and you get this curve that's spiked real on the top and then tails off real sharp over, on the right side. Okay. Then that remaining amount goes through the same cycle. So it tends that those that get phased out are just out of the next cycle and the next cycle and the next cycle. This would lead one to conclude that the most effective way to assist those experiencing inequitable levels of poverty is to assist them in increasing their human capital rather than simply handing out standard income. Now, I'm not going to tell you what I think is the solution based on the Pareto principle, but I'll tell you, Cynthia, that I think you're getting very close. I've worked in the not-for-profit world for many, many years, and I've worked in places in which organizations just give money and organizations spend that money increasing human potential to stay in the game and keep making trades, as it were. I don't mean stock trades, but I mean, interactions. And looking at that data, the effectiveness of staying in the game and making the trades tends to be much better than just giving money. If they are able to increase their productivity, they'll improve their economic situation, which supports the adage asserting that money problems cannot be remedied by simply adding more money. Okay, that's kind of what I wanted you to get at, is this is a mathematical principle that seems to run. Now, for your own self, I mean, you look at that, and that can be a little unnerving. You go, damn. So like 80% are going to end up with most of the stuff. 20% are going to end up with 80% of the stuff. And sometimes it's even more skewed. It's like 10%. And then all the rest of us are out, in the cold. How do I stay in the 10 or the 20 and out of the 80 or 90? That's the question. Well, part of the answer is you stay engaged in the exchange. Because if you don't, if you taper off onto that zero and you stop the exchange, now it's not a guarantee that staying in the exchange moves you back into the 80 or 90 percentile, but it is a guarantee that removing yourself from the exchange puts you into that, 80 to 90% that are left out in the cold. Okay. And it's just the way it is. All right, question number 4, according to Alan Smith, why should all people be interested in statistics? Richard, let's see what you said. Alan begins his lecture about how many people in the UK lack type 1 numeracy skills, particular subset of these skills of statistics. Mr. Smith continues to go on using his personal experience about how significant amounts of OECD population present standard numeracy skills, especially statistics. And this is true here. People just don't understand numbers. I agree with Alan Smith's lecture that statistics is the source, is the science of us, that people should be more interested. Yeah, basically the bottom line is you should be interested in statistics because it's the study of us, and we should be interested in us. Statistics is observable and testable data that can disjoint and debunk a person's misconceptions of reality and help us get the truth to find logical solutions. True and true. Now, why you might be saying, good answer, by the way. You might be saying, Richard, you might be saying, well, why doesn't everybody embrace statistics? Well, this is a very common human behavior. Many people don't want to know the truth. And I don't say that as some sort of a judgy thing. Okay. I would tell you as a communication professional, be very, very careful about the stories that you tell yourself about yourself, because we tend to believe our narrative about ourselves. And if, as is often the case for all of us, your narrative is not grounded in an analysis of careful observation, that's me too, then the story that you tell about yourself, and you will believe you, may not be grounded in that reality. And that can be a problem. That can hurt you. Okay, so be careful about that. And that's why you should be interested in statistics, because it's the study of you. All right, guys, crew, everybody, longer video today than normal, but there's some things I wanted to cover. Important concepts and attached terms that you need to get. Lock them up there for your use and for your midterm and your final exam. All right, so have a great week. I think about you, I pray about you all the time. And I will see you on Canvas. Take care. Bye-bye.